Good afternoon and welcome to this Wet Centre webinar with me, Scott Raffle, brought to you today from the AHDB. This afternoon, we're going to be learning a bit more about the new technology that's being used at the Wet Centre this year, the work plans that we have in hand, and you'll be hearing from some of the contributors to the new technology on demonstration at this year's Wet Centre. So before we get into the Wet Centre webinar itself, a few housekeeping rules. All attendees are muted. You can hear us, but we can't see you. You can see us, but we can't see you. But don't worry, there is an opportunity for you to ask questions. There's a little mock-up of the control panel on the right-hand side of my screen there. And if you look down, about halfway down, there's a little bar that says questions. During the presentations today, you can click on that bar and submit the question, and we'll have an opportunity to pose the questions to each of our speakers at the end of their presentation. There will be basis and also forms available for this event, and you can complete those. If you want to do that during the event, again, on this little mock-up bar here, you will see an Excel spreadsheet there that says basis. And if you click on that, you can download the form. You can complete the form with your name and registration details, and you can then submit that by email to Claire Sayers-Smith, my colleague at AHDB, who's helping to run today's webinar. There is her email address. So it's claire.sayers-smith @ahdb.org.uk. I will show that again at the end of this afternoon's event. I should also say that this afternoon's event is being recorded, and we will make it available at the AHDB website, hopefully by next week. So for your colleagues or friends that haven't had the chance to watch it, or if you wish to watch it again, you can view it on our website. So why are AHDB involved in the Wet Centre? Well, quite simple, really. AHDB, over a period of many years, have funded Mark Else, the physiologist at NIAB EMR, and his team to do a lot of Wet Centre work or water efficiency technology work on both strawberries and raspberries. And after the Wet Centre was set up in 2017, AHDB felt that it was sensible for us to be involved to ensure that the results of research that we had originally funded could be demonstrated and promoted to the industry. So that is our involvement, and I'm here as a Knowledge Exchange Manager at AHDB to help to promote the results of the work to you, the industry. So the programme for this afternoon, we start with Mark himself. Mark runs the Wet Centre and manages the Wet Centre at NIAB EMR. He's going to tell us all about the work programme and the plans for this year. Then we'll have 4 speakers from different partners of the Wet Centre who are going to tell us about the technology that they're bringing to the centre this year. We'll have Giz Gaskin from Yara UK, John Newstead from Delta T, Julian Gruzelier and Robert Mitchell from Netafilm, and then Antonio Llorente from Stoller Europe, who will tell us more about what they bring to the Wet Centre. But I'm now going to introduce our first speaker, who will be Mark Else. Mark is a hormonal environmental physiologist whose research focuses on understanding and manipulating crop and environmental interactions to deliver improved resource use efficiency. Good afternoon, Mark. The floor is yours, and please tell us all about this year's work programme for 2021.
Good afternoon, Scott. Just checking, can you see my slide?
Yes, we can, Mark. Thank you.
Excellent. Thank you, Scott. So yes, thanks for joining us, everyone, for this afternoon's webinar. So we'll just provide a summary of the work we're going to do this year at the Wet Centre. And of course, this year we hope that you'll be able to visit us later in the next few weeks and months, so we can see things in 3D and in real life. And we're very much looking forward to welcoming visitors back to the Wet Centre. So you'll see there, this is a slide that sort of shows our partners in the Wet Centre, and I'm very pleased to say we'll be hearing from many of our partners today. We'd especially like to welcome Yara, and we'll hear from Giz shortly about the technologies that Yara are bringing to the Wet Centres, and so we'll just move forward. Just thought I'd give you a brief overview, a sort of a very detailed picture of the map in the Wet Centre. As I say, hopefully you'll be able to come to visit the site, and we can talk about these in more detail. you'll see here, if you can see my pointer, this is where we'll be testing some of the Stoller products that Antonio will talk about later. Here we'll be testing some of the Yara products that Giz will mention. Here we have some new sensors that Delta T have recently released, and John will mention those as well. And Robert and Julian will of course tell us how we can improve water use efficiency in substrate systems such as these. So this is just an overview of some of the treatments within the wet center, and just an idea of some of the sensing technologies we've got there to gather the data to help to inform our decision making. Now, one thing that, although most didn't visit the site last year, you may remember in these tunnels here, hope you can see my mouse pointer, we had the Lumitect yellow plastic film. And so I haven't really had an opportunity to talk about that until very recently. So I just thought I'd start off with a look back into some of the results from last year, just on the Lumitect film specifically. Just a couple of slides just to show you what we were doing and what sort of things we were investigating. So this is a picture taken probably beginning of last season. You'll see there, so you're looking west on this photograph. So the tunnels on the left are the advanced, where you can see the automated roof vents. Tunnels on the right then are the commercial area. And all of the results I'll be reporting for the Lumitect plastic, of course, were generated from the commercial area, where we don't have this confounding influence of automated venting. So the idea then was to design a film in an Innovate UK project that could disrupt pest behaviour, and there have been very positive results reported by my colleague Michelle Founting and other collaborators on how this sort of type of film can disrupt pest populations such as SWD and Western flower thrip. And I know there have been some very positive effects on sort of pest populations in some of the commercial work that's been done. So I was more interested in understanding the effects of this film on plant physiology and on important agronomic traits such as photosynthesis, water use, fruit quality and fruit yield. And so just to be clear from the outset then, that it's a very small scale trial at the wet center. It's just on 1 year and with one variety, Marlin Champion. But as I say, I was interested in understanding the effects of the films on plant morphology and physiology. So if you've ever seen these tunnels or been under those tunnels, you'll notice it's a very different light environment. And of course, one immediate thing we see then is a reduction in the transmission of light in the plastics. And so you can see there in the graph on the top left, this is the typical, I think this was on the 24th of June last year, a bright, sunny, cloudless sky at East Marling. And you can see the sort of diurnal pattern of PAR. So that's the light that is drives photosynthesis. This is a diurnal pattern outside the polytunnel. This is the level of PAR we see and the changes over the photoperiod in the clear plastic. And you can see here then there's quite a small but significant reduction in PAR coming through the Lumitect plastic. And if you add those differences up over the season, then you begin to see these differences here shown in this bottom graph on the left-hand side. The accumulated PAR value is then under the clear plastic is this line, and you'll see then there's this growing disparity in PAR penetrating through the Lumitect plastic as the season progresses. And so on average over the season, or at the end of the season, sorry, there was 17% less light PAR coming through the Lumitect plastic compared to the clear plastic. And of course, you'll have probably heard me mention before that last year, certainly in terms of PAR, was an exceptional year. And so this is some satellite-derived PAR data derived by our partners, WeatherQuest. And you'll see here then this orange line is the accumulated PAR in 2020. And you can see it's significantly higher than the 10-year average, and also any other year in the last sort of 10 or 15 years. So basically, especially last springtime, as you cast your minds back, lots of bright sunny days where PAR was very high. And so even under these very high ambient PAR levels then that we saw last year, there was still this significant effect of the plastic on so reducing some of the light intensity. And so, as I mentioned, we were very interested to understand what effect that might have on yield at our wet center and with Marling Champion. And you can see here, this is the sort of the pattern of harvesting over the season, and this is then the accumulated total of class 1 fruit. And you begin to see from fairly early on, then there's a negative effect on class 1 yield in plants that were grown under the Lumitec plastic, and that was partly because there was probably more waste fruit per plant under Lumitec plastic, and also due to the fewer number of class 1 berries per plant under the Lumitec versus the clear plastic. So this fairly significant impact on yield potential in this particular variety last year. And when we investigated the effects on plant morphology, we tended to see longer trusses, longer petioles, longer trusses. The leaves were larger and thinner. It's a very different lighting environment, as you can see from some of the photographs. The propensity, I think, for trusses to be more prone to kinking, and you can see this here because they were longer and thinner. And if we looked at stomatal conductance and also plant photosynthetic rates, we saw a significant 18% reduction in photosynthesis and also stomatal conductance in those plants grown under the Lumitec plastic. So although a lower stomatal conductance helps to conserve water use, and so might expect a higher water use efficiency, of course this reduction in the rate of photosynthesis is quite significant and probably contributed then to the lower yields and also then to the reduction in average Brix values that we saw in those plants. So that was just a very quick summary of the research into the Lumitec plastic last year. Again, it was 1 year with one variety, and I think some growers have reported very positive effects with different varieties, but certainly in our hands, Marlin Champion at the Wet Centre, we did see this negative effect of Lumitec plastic on class 1 yield and quality. And I mention that really because it's the important part of that story, I think, is the light, and we'll come on to the light later and how we want to optimize the lighting environment within the Wet Centre to drive yields and fruit quality. And so Scott mentioned we'll hear from many of our partners this afternoon, and so I'll leave those guys to explain the sort of technologies and experiments that we're doing at the Wet Centre this year. So we're using or planting Marlin Champion again this year. So we planted mini tray plants on the 31st of March. Last year, you can see here, then we averaged just over 1,200 70 grams per plant, so very high class 1 yields in 2020. So we're keen to see then whether we can match and indeed exceed those high yields that we saw last year from this variety. So a couple of photographs to show you what we've been doing over the last few weeks and months. Lots of sensors installed. This one is a PAR sensor, so lots of sensors installed in the different rows to give us even more information on how those different positions, those zonal phytoclimates affect plant productivity and quality. I mentioned then we replaced the Lumitec plastic with clear plastic, and you'll see here then some work to sort of locate and fix some leaks we saw in the Wet Centre last year. So a lot of work behind the scenes fixing those leaks. Delta T and John will talk about some of the new sensors that have been deployed at the Wet Centre this year. And this is a photograph I took last week. And so although the plants were planted on the 31st of March, it was quite cool. And so fairly bright, but quite cool. So the plants have been sitting there, of course, and they've been busy putting out new white roots, which you can see here in this photograph. And now that I took this photograph yesterday, so you can begin to see now warmer weather, the plants are starting to grow away, and we expect full bloom to be probably in 10 days, 14 days time. So the majority of the focus is on strawberry, but of course we also have the raspberry Wet Centre. I think Robert might mention that later in his talk. And so here we have Marlin Bella, and you'll see here we've installed drainage gutters now, and this lets us collect runoff from 40 meters rows. So we get a very accurate measure of plant runoff, and so we can begin to, or even better, sort of control and match demand with supply, and making sure we're increasing the water use efficiency of those particular plants. So you're probably aware from last year's presentations that we have a couple of Innovate UK projects that we're hosting at the Wet Centre site. And the first then is Berry Predictor. And this is really trying to understand, as I mentioned, the impact of these zonal phytoclimates on crop productivity. So all growers will know that the leg rows behave differently to the centre rows, and they behave differently to the middle rows. But what we're really trying to do is quantify those differences, so growers can make an informed decision on whether it's worth intervening to try to raise productivity and perhaps income by, as Robert will tell us later, making every plant as good as the best plant. So that's one part of the project, and the other part of the project, of course, is to better predict the growing environment within the crop, but also then use that information to more accurately predict rate of ripening and the production of class 1 yield. And so we developed various models over the last sort of 18 months, and we're very keen to start to test those this season, just to see how accurate we can be in terms of predicting and forecasting yield and plant fruit quality. I think I showed this table before. It's basically a table summarizing the effect of the different rows. So row 1 is a leg row, 2 is a middle, 3 center, 4 center, 5 middle, and 6 is a leg row. This is on the east of the tunnels. This is on the west of the tunnels. This is on the east of the tunnels. And you'll see, as I've mentioned before, this good correlation between the amount of light intercepted by the plants and the yield potential of those plants. So the more light we get into row 4, the higher yield we see. And we see this pattern both in the commercial area and in the advanced area. And I've highlighted the two leg rows there, rows 1 and 6. So row 6 has significantly lower yields than the other rows. Row 1 is very interesting because per unit of light intercepted, those plants are delivering 10 or 11% more yield than we would expect in terms of the par alone. And we don't think this is a temperature effect because we've got very detailed temperature comparisons between the rows. And we know that generally temperatures in row 1 are very similar to those in row 6. So interested to understand what's driving this higher productivity per unit of par. We think we know why that might be, and so we'll be testing hypotheses this year to see if we're correct. And of course, the idea is if we can understand why those plants are even more productive than we perhaps think they should be, that might be an opportunity then to raise the productivity across the other rows as well. So that's an area of sort of work that's ongoing, and I'll hopefully be able to update you later in the season during the visits, or perhaps in another webinar later on in the season. And then just finally, then we also have a program on the raspberries at the Wet Centre, really trying to better target nutrient demand with supply. And so this is a combination of using nutrient demand models that we've developed in an Innovate UK project led by Berry Gardens over the last few years, and really integrating that with artificial intelligence-based real-time sensor systems for NPK, and of course with the precision fertigation systems that Netafilm provide us with. And so this is just a schematic to say we're integrating the nitrogen demand modeling. We know we can reduce nitrogen inputs by 30%, and that doesn't have any effect on yields and quality. Integrate that with the AI-based sensor system and the precision dosing system. And the idea is to better match demand with supply of the growing season. So we reduce emissions to land, air, and water. And of course, a key element of this is trying to reduce the production of greenhouse gas emissions from intensive horticulture. So that's something we'll be measuring and perhaps reporting on later in the year. And so I think that's me. I'm almost out of time, but I'd be very happy to answer any questions if there are any, Scott.
Thank you very much indeed, Mark. Yeah, very succinct and very helpful update on the plans for this year. If you do wish to send Mark a question, please use that question box on the little control panel hopefully on the right hand side of your screen, and do deliver a question. Mark, I've got a couple that I'll pose to you. First of all, I suppose this year has been a late season. It's been cold, it's a cold start to the year, and growers have traditionally said a late season is always a poor season, they never catch up. Is there anything that technology can do at the wet centre to mitigate this problem? I know you can't change the weather. Is there anything, any technology that could be used or demonstrated in future to overcome this problem that we get in a late year?
Yes, I think obviously we have sort of the auto venting and the vented doors, so we can sort of close the systems off, you know, that many growers do. But we're very interested in seeing how we can better control the environment, and that might be it might be lighting through LEDs, it might be CO2 enrichment, it might be heating wires within the growing system. And so I think hopefully I'll be able to talk about the next phase of the expansion of the wet centre next year, and that's a project I hope to be able to, as I say, to put forward and then to begin work on next year. So I think there are ways in which we can optimise the growing environment to sort of combat these, you know, these inevitable challenges we see every year, whether it be too warm or whether it be too cold.
Thank you. And another question I would put to you is something that has been talked about a lot in the industry in recent times is the use of oxygenation in water. I know we've discussed this off air, but I thought we'd just mention it on air now. Is this something else that could be looked at in future at the wet centre? And indeed, is oxygen a limiting factor for growers? Any views on that?
So I think it's a very interesting area, yes. And so I did my PhD on soil flooding in tomatoes many years ago. And so hypoxia and anoxia, of course, are sort of stressors that are related to soil flooding. So I've got a deep-seated interest in sort of oxygen responses and low oxygen responses. So I guess first we need to be able to sort of measure the oxygen partial pressures within the coir, to see perhaps whether frequent irrigation events are perhaps inducing hypoxia and anoxia in perhaps at different times during the day. But I'd be very interested as well to see some of the sort of the research and the data that support the you know, the idea that oxygenation can help to improve yield. And so it's certainly, I think it's got something we'd be very interested to look at in more detail.
Good. Thank you, Mark. I think we must move on. Just a reminder, any more questions or anything that Mark's been talking about, do submit them on the question box there on your control panel. Thank you for now, Mark. Do stay with us in case you are asked to provide us with any more answers later on. We're going to move on now to Giz Gaskin from Yara UK, and in Mark's presentation he did explain to us that Yara is a new partner within the wet centre this year, and I'd like to welcome Giz for the first time on this platform. Giz is an engineer by training, and he trained at Harper Adams University and also at Swansea University. He has worked in the horticulture sector for many years. For the last 15 years, I've known Giz in various guises. He has worked for a well-known UK propagator, and as of February in 2020, Giz took on his current role with Yara UK, and he's going to tell us a bit more about what Yara are bringing to the wet centre. Good afternoon, Giz.
Good afternoon, Scott. Thank you very much for giving this opportunity for me to have a discussion with your growers. I'm going to take a short moment to talk about what Yara will bring to the wet centre this year. But before that, I'd also like to thank Mark for all his help in getting Yara to the wet centre this year. Okay, I'm going to talk first a little bit about climate change and Yara, and then move into how that affects us in terms of trials at the wet centre, and then look at things that we are servicing, services we want to display and test, moving into key products and services, etc. So climate change, the Paris Accords have just about come in, and Yara has been impacted in two key areas. One area as a manufacturer is the impact of the reduction of CO2 emissions by up to 30%. And the second aspect is the reduction or helping in the reduction of ammonium use in fertilizer, also by 30%. In terms of CO2, this is driving Yara towards what we're calling green ammonium, which is the production of ammonium nitrate mainly via renewable energy and solar and wind. This is a product which will probably take a few years yet to come out, but the idea is very much against the Paris Agreement to allow us to reduce that carbon emission rating. The second aspect is a little bit more difficult. The reduction of ammonium in fertilizer is a tricky step. mainly as ammonium is quite useful when it comes to agriculture as a whole. Yara believes that the key to this is mastering the micronutrient and biological stimulant ranges in order to get a better efficacy of the crops. Working with the rest of the industry, we expect in the next 5 to 10 years to be able to look at the reduction of macro inputs against the micro inputs. And very much for Yara, this partnership with NIAB's EMR Wet Centre is the first logical step. So what we want to test at the Wet Centre this year, we have Yara Vita Actisil, which is a silicon-based product, has benefits on fruit for shelf life, which we want to explore at the Wet Centre to understand better how the density of skin and structure thereafter increases, if possible, shelf life. We also want to take a look at how it reacts as a root stimulant. At the bottom, you can see a photograph which was taken last year in a trial with a UK propagator, which demonstrates the effect Actisil has on the root structure. This was after only one application. Actisil is seen to increase the fibrosity of the root structure against the control, which we believe will then enhance its ability to uptake more nutrient against the surface area increase. Yara Vita BioTrack is based on Ascophyllum nodosum, which is all about enhancing cell multiplication and aids the roots when it comes to stress. But as compared to Actisil, BioTrack very much works in case of increasing overall mass. So when you think about it, how it benefits the root structure, it benefits it by increasing the mass of rooting, as opposed to Actisil, which changes the way in which the rooting structure becomes. This year, what we're doing is we have a single trial where we're going to use Actisil alongside BioTrack, which will allow us to look at both the shelf life impacts of Actisil and the increased cell multiplication of BioTrack. But at the same time, we'll get the benefit of looking at the rooting system afterwards to see how Actisil may have impacted the rooting system and whether BioTrack may have increased the overall mass of that rooting system. Yara Vita Stop It is an older product, usually used for the control of bitter pit in apples, but it's also been in use across UK and across Spain in many soft fruits, mainly for enhancing shelf life and improving skin quality. We want to re-explore this work at the Wet Centre this year so that we can better understand how it's doing it in terms of strawberry and the benefits to shelf life, mainly because the calcium content formulation of Stop It may well be useful in future Yara Vita products. Yara Vita Ferritrac is very new and has just been released. It's a new EDDHA ortho iron. It's a very safe iron to use. It's not a messy product at all. It's very easy to handle. That's all thanks to its liquid formulation. In trials this year, we're testing this in orchard crops and viticulture crops. In strawberry, we want to test it through the fertigation system to see if we can ascertain, is the rate correct? And also, how does the plot look in terms of iron uptake within the year of application? In terms of display, we have two things we want to look at. Firstly is the Yara Field Box, which was described to me as an espresso for fruit. This system is largely based on Yara Terra Easy Feed, which is in use in the EU at the moment. Easy Feed, to contrast the two, Easy Feed is all about liquid delivery of nutrients to the A and B tank through this box system, whereas the Yara Field Box is expected to run on powdered or prilled product. So that's the distinction between them. The idea is very simple. Once installed, the Easy Feed system allows the grower to input almost any combination of nutrients into his A and B tank, and then obviously into the crop. But in terms of how it works from Yara's side, Yara is then responsible for the supply to that box, and everything back from the A and B tank to the factory is run on a just-in-time manufacture system. In the EU, this is a lot easier for Yara because most of the factories are quite close to most of the facilities that are using it. Whereas in UK, obviously, we've got the channel to consider. So that's why we'll bring the field box across to NIAB so that we can have a closer look at the hardware involved, but also then we can open the discussion on how we're going to run this box in the UK. The second aspect is the Yara N tester, which is all about cereal nitrogen. It backs up to at-farm. We've brought an N tester to the wet centre, mainly to decide and discover how it reacts to strawberry leaf. In an ideal world, it should be a simple step to configure it for strawberry rather than cereal product. And if we can achieve that, then we can look at using at-farm more extensively for strawberry than cereal. Key product areas, Yara Vita, which is mostly what we're testing this year, foliar feeds, micronutrients and biostimulants. Yara Terra is the fertigation solutions, and Yara Milo prilled and Schaefer liquids. Key service areas, Yara Analytical and Agronomy. Yara Analytical will be helping the wet centre with most of the sampling this year, and something which we will look to expand on in future years. Yara Digital, the latest thing to come out is the Yara at-farm app, which is looking very powerful and takes on from Yara IREX in terms of the use of the N sensor and, as mentioned, the N tester. Thank you very much. Any questions?
Thank you very much indeed, Giz. Again, very succinct presentation and very helpful just running through all those products. One thing I would put to you is sticking with the discussion I had with Mark earlier about the cold start to the season and the delay in production that may cause. Have you done any work with Actisil, which you talked about as a root stimulant, in terms of comparison between different temperatures? So will it make a bigger difference, for instance, in a year like this, which is cold, and that might encourage more rapid root growth, whereas you might get that more rapid root growth in a warmer season? How much comparison have you done, or is it possible to do that in future?
I think that's something to look at in future. In terms of Actisil and its root stimulation, work we have looked at is more relating to turgor pressure and how it controls the stress in the root zone as you move through these periods. In terms of the actual temperature differences, I think that's something we can look at.
Yeah, I think that might be quite useful. And the other problem we have sometimes in the opposite, in a contrast situation, when you have a very warm year, sometimes on strawberries you get a lot of top growth at the expense of root growth. So again, that would be interesting to look at that. Hence the reason for my question about temperatures. A couple of other questions before we move on. First of all, do we know the values for strawberry if you're using the Yara nitrogen tester, the Yara N tester?
No, that's what we're aiming to find out.
Okay, so
we have a set of parameters within MegaLab that we can rely on, but it's a question of getting the N tester on top of the strawberry, seeing what the readings are, and then relating it back to MegaLab to see how we can control it. Okay,
so good. And one last question. Silicon-based products have been shown to help protect strawberries against powdery mildew by thickening the leaf cuticle. Are you aware that Actisil has these properties too? I don't know if that's a comment rather than a question.
We're not allowed to sell it as a agrochemical style product. It's certainly not listed for that, but we are aware that it has potential to increase, well, it increases the skin density. And from our understanding of it, it blocks up the holes that potentially the hook of zoospores may link into. So it does have an effect of suppressing mildew, but it can't be sold as a mildew suppressant. It is a micronutrient.
It's not a plant protection product, is what you're saying. Yeah. Good. Giz, thank you so much. We've run out of time. We must move on, but very grateful to you for your presentation and giving us an update on all the Yara products, which will be included this year. Thank you for now. And we move on. And our next speaker is John Newstead from Delta T Devices. John is a soil scientist who trained at Reading University. He's worked for many years in the industry as an environmental consultant and as a soil scientist. And for the last 10 years, he's worked as an environmental engineer at Delta T Devices, working between the sales and development teams, and he's been a director of the company for the last 6 years. John, tell us what you're going to bring from Delta T to the Wet Centre this year.
Thank you very much. Hopefully you can all see my presentation. Thank you very much for the introduction, Scott. So my name is John Newstead. I work for Delta T Devices, and for those that don't know us, we have been designing and manufacturing environmental monitoring equipment for 50 years. This is our 50th year. So you may see some emails and so forth going around about that. We're quite proud to actually be associated with the Wet Centre, Centre of Excellence, and also it gives us an opportunity to display our equipment and see it being used in a practical, applied fashion. You can see it in action, so it works very well for us to be a partner. What kind of equipment does the Wet Centre actually use of ours? Firstly, when you walk around, you'll see these blue boxes. These are GP2 controllers, data loggers and controllers. They have 12 analog channels. Importantly, and I'll come back to this in a moment, they have an SDI12 input. So you can have one cable going into the SDI12 channel, but you can have 55 to 60 SDI12 sensors attached to that single cable. So I'll come back to that at the end of my presentation when I talk about a new sensor. It can have 6 relays on it, so you can control six experiments, 6 irrigations. Those relays can also control doors, windows, pumps, motors, that type of thing. It comes with a script editor, so to you and me, that means it's programmable. So if you have an environmental parameter that can be described with an algorithm, mathematical equation, then you can put that on the logger and output that as well. So over the years, 5 or 6 years it's been around, it's proved itself to be highly flexible and adaptable. Many of you will be familiar, I hope, with the wet kit, multi-parameter, so substrate moisture, EC and temperature. It's proved itself to be robust, reliable, a real workhorse for us, in fact. We sell lots of these, and it is the only sensor on the market where the thermistor is towards the base of the central pin, which gives you accurate or the most accurate root zone temperature and a good EC temperature correction. And for those of you that do install your sensors permanently and do time series monitoring of changes in your substrate properties, you may be using the SM150T soil moisture and temperature sensor. This is proven, established, reliable, been around for a long time, and thus it comes with a 5-year warranty. So it's plus or minus 3%. So it's proved itself to be quite a reliable sensor. And lastly, you've heard a bit from Mark earlier about the amount of power work that's being done at the Wet Centre, rows being affected, yields and quality being affected by power. We obviously also have our power sensors installed in the Wet Centre. So I should say these sensors and loggers, these are all about measuring, monitoring and controlling. But that's all very well and great, but everyone wants to be able to visualize their data. And for that, Delta T have been using at the Wet Centre the Delta Link Cloud, which is a free, no subscription and secure website. So once you've bought the actual infrastructure, other than your standard cellular charge for using a SIM, it is a free site. So it's easy to use, file sharing site. Allows you to view on tablets and phones as well as your laptops, but we all really don't necessarily want to have or to look at the last 2 months worth of data outputs. There's a lot of data there to look at. We want to see what's happening now, instantaneously, and for that there is the option of moving to dashboards, which give you spot checks on your sensors, so you can see what's happening now or over the last couple of days. Essentially streamed to your fingertips. So that's all visualization. And it's important to note that whatever visualization package you use, all that data is always presented in a form that looks very accurate. So just looking at that dashboard there, it says 59.9% volumetric moisture content. Perhaps that could have just been rounded up to 60%. But nevertheless, it portrays an image of a great precision. But I would ask, how accurate is that data? And that accuracy is based on the sensors that are producing this visualization. So in our case, it would be the stuff you've just seen, the SM150T sensors, the PAR sensors. If you've got good quality sensors, you've got good quality and reliable data, and therefore you can have a lot more faith in this visualized format. What does that all look like in the wet center itself? If any of you haven't been, I recommend you do go. GP2s are quite obvious, nice big blue boxes there. This particular one in the picture, there's quite a lot of cables on it. Each one of those may be going to an SM150T sensor. We can change that now, as I'll explain with our new sensor, but it's rather neat and tidy. The bottom picture, that just shows one of the sensors. If you look at where the red circle is, that shows where the sensor has been installed in the bag. And to the left, you've got a schematic of the whole setup. So you've got, there's actually 6 sensors going into a GP2, which is averaging the data. And that data is then being sent to the Netafilm irrigation system, telling it when to irrigate and how much to irrigate. And obviously here we've also got the Delta Link Cloud modem link, so you can actually have a look and visualize what's happening. So that's what's going on in the wet center from Delta T. But I have mentioned several times about our new sensor. It's called the Wet 150. You may be seeing adverts appearing from it from now onwards. And we would like to think it's being pitched at a pretty low price, which makes it affordable to people. It will measure water content, EC, and temperature. So for water content, it's plus or minus 3%. The temperature range goes from, I think it's minus 20 to plus 60, and it will measure to 2000 millisiemens EC. So it's actually, in terms of its specs, slightly better than the Wet 2 sensor, which I showed earlier in its portable format. Because it comes with a 5-year warranty, which I'd like to think would, when you see that on any manufacturer's sensors, I'd like to think that gives you a peace of mind. It's a reflection of perhaps the robustness in terms of its construction. So it should give you a little bit of peace of mind that the money you're spending will actually last. But importantly, this sensor, it's an SDI12 sensor. So most of our other sensors are analog outputs. So each one of those sensors requires a separate cable. When you've got an SDI12 sensor, you can have one cable, let's say going down your whole tabletop, and you can have little branches off that going to individual sensors. So an SDI12 cable can have 55 odd sensors attached to it, should you wish to do that. The wet center, we've just installed 5 on one line. So we're hopefully excitedly waiting to have a look at the outputs of those at the moment. So I should just say SDI12, for those that don't know what it is, it's a digital output, that's all. It's a digital sensor, okay? It's relatively easy to set up, and it's relatively easy to set up quite large sensor networks. And we'd also like to think at Delta T that we provide great technical support for that. So if you do have any problems, you can give us a ring and we'll sort that out for you. So that would be the end of my short presentation. If anyone's got any questions, perhaps Scott, you can tell me. I can't see the screen at the moment. All I can see is my presentation.
Thank you very much indeed, John. Yeah, just a couple of points. First of all, you mentioned people who haven't been to the Wet Centre might like to come and have a look. Fruit Focus, we hope we'll give you that opportunity this year on the 21st of July, all being well with the removal of COVID restrictions, then Fruit Focus will go ahead. Let's all hope indeed that happens. But Mark Elson and his colleagues are always rushed off their feet at Fruit Focus because so many people are so keen to come and have a look at all this new technology. So do use the opportunity to come down to NIAB EMR at the Fruit Focus show on the 21st of July. Just picking up on your talk, John, I suppose you talked about the 5-year warranty. My question would be to you is how important is it to actually check sensors? Should they be calibrated? Do we need to check them in a way? Because of course, like everything, things can break down within the 5-year warranty spell. Should growers who are using your sensors be conducting checks or cross-checking?
It's a very good question. The official line would be that the manual states, I think it's every 3 years, you could get them checked if you so desire. From a practical viewpoint, sensors are buried, they're not always accessible. And that goes for every manufacturer and every type of soil or substrate type sensor. And also from practical experience, we've had sensors that have been buried continuously for 10 years and they have been returned. And in those instances, the variation that was found to be still within the actual, there was variation from the calibration, but it was actually still within the spec of the sensor. So in reality, one could expect a very small, if any, calibration drift. If you want to have your sensors checked, please do send them in. It's probably good practice every now and then to get some checked. But like I say, in reality, they don't seem to need much.
Okay,
put them in and leave them to it.
My thinking, being a Scotsman, is that there's so much money tied up in these production systems that we don't want to lose a lot of money based on a faulty sensor. But that's useful to have.
Absolutely. But I mean, don't forget, it's a 5-year warranty. That's a sign of. We'd like to think it's a sign of faith in the product that it is going to last. You shouldn't have any problems. It does what it says.
Wonderful.
So that's worth bearing in mind. I should have said also. Hope you don't mind. But, hopefully towards the end of this year, we'll also have a radio system, a wireless system that could work within polytunnel environments. So we'll have a range of options, communication options for customers when they've got their sensors in.
Okay, so new products coming out of Delta T. Thank you, John. We must move on. Very grateful to you for your time this afternoon. Thanks again. And we will move on now to Netafilm UK Limited. Now we've got a double act from Netafilm this afternoon. We have Robert Mitchell, who's the Managing Director of Netafilm UK and Commercial Director for Northern Europe. And we have Julian Gruzelier, who I think is known to lots of you as the Chief Technical Officer for Netafilm. And Julian is also Head of Agriculture, Horticulture for Netafilm UK, working with leading growers also in Egypt on behalf of Netafilm. So very warm welcome to Robert and Julian. Tell us all about what Netafilm is bringing to the Wet Centre this year.
Okay, thank you, Scott. I assume you can see my screen.
We can.
What I propose to, thank you. Okay, as Scott said, Julian and I are going to double up on this presentation. Firstly, I'm going to talk a little bit about why we're at the Wet Centre, what we've done in the past, and then introduce 1 or 2 things we're going to do in the future. And then Julian will drill down into a deeper application, and we'll wrap up hopefully with some interesting product information. So let's start with why Netafilm at the Wet Centre. And as Mark mentioned earlier, my obsession on farm is to try to ensure that every plant is as good as the best plant on the farm. And we strongly believe that the way to do that is to ensure that each plant is given the same love, care, food, drink, etc. as the one next to it. So uniformity is our goal, and that's one of the main reasons we're in at the Wet Centre. But we want to grow more using less. So we want to use less energy, less fertilizer, less overall inputs, including water, time and labour. So I remember in the last presentation, Julian talked at length about the heart of the system, the PCJ dripper, and I'll refer back to this later, but this is the engine which ensures that each and every plant gets the same amount of water and fertilizer, independent of the length of the lateral or the topography of the site. We also talked last time about the rig, the 8-channel rig, where we were looking to ensure that we could actually give plants individual components of fertilizer rather than a mixed compound, so that we could give each and every plant exactly what it needs, exactly when it needs it, and avoid waste of fertilizer, energy, etc. But that's enough for the past. Let's talk about what we plan to do going forward. In 2021, as well as supporting NIAB EMR with things like improving filtration on the rainwater harvesting system, we propose to look at this product for the Wet Centre. It's called Net Flush, and effectively it ensures that the drip lines and the main lines of the irrigation system remain free of debris and algae buildup, which ultimately can lead to poor distribution, non-uniformity, and even damage to the system. This product, which we hope to install during 2021 at the Wet Centre, will provide automatic flushing of the lines with minimum labour input, and it should provide a cost-effective solution. So if we can put this in at the Wet Centre, we want to achieve 2 things. One is to demonstrate it, of course, for other people to see, but obviously importantly to ensure that we have the optimum efficiency for the irrigation system at the wet centre. Now I'm going to hand over to Julian, and Julian's going to talk about challenges in container growing. So Julian, I'll hand this over to you, and then hopefully I can provide a solution to the challenges you raise. Julian.
Okay, thank you. So yeah, we obviously work with growers, and we're looking at the challenges that face the existing systems in the marketplace. And in this slide, you can see what we call a spider system, which is a set of 4 drip stakes, drip points, connected by microtubes to a hub dripper. And you can see, you know, there's a lot of tube and stuff there, so it's very easy for that to be disturbed while people are working in the crop. Now, this is another system where you can see the hub dripper is using 2 leads, 1 into each pot. This is designed to 1, reduce the cost, but 2, reduce the risk. So actually, if one of the stakes gets knocked out, the pot isn't affected. The pot has still got 1 drip point in it, and it will stay alive. But one of the problems with the having infrequent drip points is, as we see in the picture on the left, you can get very limited wetted areas, which on the edge of those you can get salt buildup, and that salt buildup prevents the roots from growing into the entire volume of compost. Now, to overcome that, we can increase the number of drip points, as we can see in the picture on the right. This gives us a much better rooting within the pot, but also it costs us more and gives us more microtubes and drip stakes to install. And you know, installing a drip stake we think is a simple task. It's not, especially in medias that are very open. If you push the stake in too far, you can see that water actually comes off the bottom of the stake, bypassing the top layer of the compost. Now, in certain crops, blueberries for one, that's very shallow rooted, that can be quite detrimental to the crop's performance. And you know, let's take a look at this picture. If you've got a lot of pots, you know, we're relying on the people, the personnel installing the irrigation to put all the stakes in the right place all of the time. And for argument's sake, you've got 10,000 pots, you might have 40,000 drip points that you need to get in the right place. And that doesn't always happen. So we were looking for solutions, designing solutions, trialing solutions. And this is what Robert will go on to explain.
Thank you, Julian. Yeah, I think Julian's highlighted the fact that what we really want is multiple outlets, easy to use, that are going to provide good water distribution, good nutrient distribution in the pot. And that is why Netafilm have developed NetBow. And this is something we propose to install in the wet centre, probably in 2022. What is NetBow? Well, it's a horseshoe-shaped device containing 8 of Netafilm's high clogging resistant drippers. So you can imagine if you've got 8 drippers in the pot, evenly spaced, you're going to get very good surface distribution of the water. It's easy to operate. It's a horseshoe. You put it around the plant. It's supplied with spikes which can be fitted in order to retain it in the soil. Once in place, it will remain there. No potential for damage, no potential for anything to cause it to be disturbed. Of course, the NetBow takes care of uniform distribution at the top, but we do need to rely on our old friend, the PC dripper, to ensure that the right amount of water gets to the pot. So you can install it with a PCJ dripper, a PC dripper, or with Uniram, and that will ensure that that delivers the correct amount of water to the NetBow. Of course, we're describing this as a CNL dripper, which is compensated non-leakage. Non-leakage means that the main line can remain full, which means you can cycle on and off very quickly the irrigation. And this is very important when growing in containers for crops such as raspberry, blueberry, etc. What you can see in the bottom right-hand picture is what we expect. We've got very good surface distribution of the water across the pot. And of course, gravity should take care to ensure that you get good top to bottom coverage as well, which you can see in the picture on the right with NetBow compared to the picture on the left before NetBow, where you see features that Julian highlighted, some uneven distribution, and particularly a dry surface, a dry upper layer, which can be critical, particularly at plant establishment, in ensuring you get good growth and ultimately good crop. So what does the outcome of NetMo give us? It gives us this. It gives us exceptional root distribution in the pot, and this will ensure you get good crop growth and ultimately high yield per crop. Every crop will be as good as the best crop. So why are we not doing it well next year? Well, the reason is that the current model of NetMo, which we've been discussing to date, is a 250mm version. The pots at the wet centre are 7 to 10 litre pots, so too small for that size of NetMo. But we do have coming in the next weeks and months, or weeks, a 120mm version with 4 drop-off drip points, which, as Julian explained earlier, 4 drip points in that size pot gives you excellent coverage, and this will be available shortly. We may get some installed towards the end of this season, more likely next season. So, in summary, what we hope this will provide is superb water distribution with very high clogging resistance, and it's particularly easy to use. And this should mean you will get uniform growth, an optimal root zone giving you a strong plant, and a plant with less stress, meaning much less disease. And of course, with ease of use, it's much better in terms of labour. For those of you who'd like to know more about Netafilm solutions for container growing, we are running a dedicated container growing solutions webinar on May the 25th. There'll be 2 sessions. You'll probably see it on social media, but if not, I'm sure you can contact via AHDB Netafilm, and we'll be more than happy to invite you along to learn more about NetMo and other container growing solutions. So with that, I'm happy to open up the questions. If anybody has any questions, Scott, we'd be more than happy to take them.
Thank you very much, Robert and Julian. We've got a little bit of time, but we must move on. But just a comment, somebody's made the comment that a similar system was developed by Moroccan growers some years ago. But I suppose what goes round comes round. But you know, these ideas are shared around the world. Just one question, another question too about net flush. You mentioned it's an automatic flushing system. Does it respond to debris in the system, or is it just set up to flush at set periods during the day?
Yeah. I mean, you have a control line, so you can set it up to flush single lines or multiple lines, either automatically or you can trigger it manually. Right.
Okay. Oh, that's helpful to know. Thank you, Robert. Julian, I think we better move on because time is getting a bit short, but thank you so much for your time today, and we will very much look forward to seeing the NetBo in action maybe in 2022, but thank you for sharing all that information with us this afternoon. So that brings us to our final speaker this afternoon, Antonio Llorente, who is the Area Manager for Stoller Europe. Antonio's role is to introduce Stoller solutions for fruit crops to growers. He has previously worked at the wet centre itself and is probably very well known to those of you that have visited the wet centre in its early years. He worked with Mark to set the whole centre up. So it's very nice to have him back working within the consortium of partners that we have at the wet centre. So I invite Antonio to give us some more information about your products that you're going to be promoting and developing or demonstrating at the wet centre this year. Antonio. Antonio, we can't hear you at the moment. I don't know if you're still muted. Still not hearing. There we are. We've got you now. We've got you now, Antonio. Thank you. Fire away.
Perfect. Right. Thank you, Scott. Yeah. So in this presentation, I'm gonna be showing how the Stoller products performed last year in the wet center, and I also will be speaking about what products we are testing this year and what are we aiming for. So for starters, I would like to see if the presentation moves. Yeah. I'm gonna give a little bit of background about Stimulante Plus, which is the product that we used last season. Stimulante Plus is a product that aims to keep the plant hormonal balance. The aim of this product is to ensure the enough supply of natural hormonal promoters. The claim is that this product is effective against abiotic stress and improves nutrient use efficiency. The technology behind this product, Stoller technology, is patented in the US. In order to explain how this product works, we need to look at this graph, the plant hormonal cycle, and particularly these three earliest stages of plant development: establishment, vegetative development, and flowering and reproduction. At this stage, three key hormones are very important: cytokinins, auxin, and gibberellic acid. Stimulante Plus aims to keep these hormones at the optimum level. Let me illustrate this with an example. Here we have, for fruit set, we have different hormonal concentration: in green cytokinins, red auxins, orange gibberellic acid or gibberellins. This is in optimum conditions, right? Hardly ever in our crops we find optimal conditions. Normally, what we find is suboptimal conditions. And in these conditions, the level of the different hormones is just not optimal. Look at the cytokinins and gibberellins in there, lower than it's needed. Therefore, our proposal is to use Stimulante Plus to get the levels right. The consequence of this is to get an optimal fruit set. This is fruit set as genetically determined. We use Stimulante Plus targeting yield and quality. And also for a very hot topic at the moment, as Mark discussed in the first presentation, resource use efficiency. This is the best use of nutrients, water, and light by the plant. Considerations when we apply this product: we need to apply for as long as possible during the crop cycle of the plant, integrating routine sprays, or in the fertigation program. Always perform a jug test, a bucket test, when mixing the first time. The rate of application, 1 to 2 liters per hectare and month. Application via irrigation or spray, as I said. Right, let's talk now, after this background, about the results that we got in the wet center. We use Stimulante Plus in Everbera strawberries. We applied through the irrigation from the start of the crop cycle at a rate of 2 liters per hectare. Right, what we managed to measure is that when we use Stimulante Plus, those plants use less water and fertilizer per ton of fruit. So Stimulante Plus made more efficient the plants. How much? Right. In terms of cubic meters of water per ton, these plants use 1.45 cubic meters less per ton of fruit produced, or in terms of hectares, 58 cubic meters less. Obviously, in the water, the nutrients were dissolved, and the concentration of these nutrients in the control area and in the Stoller area were the same. So we can assume that the level of nutrients used was lower. So water use efficiency, nutrient use efficiency. There was an area in the wet center where the light was limiting in terms of power, as Mark indicated earlier. And we use our Stoller product in there, our Stimulante Plus, and we managed to measure there is that if we extrapolate the results to tons of fruit per hectare, when we use Stimulante Plus, we increase the yield by 1,400 kilograms per hectare. So in addition to the water use and nutrient use efficiency, what we got here is light use efficiency. Right, let's talk now about the financials of all these results. So if we look at the overall wet center, the area where the Stimulante Plus was used, we obtain an extra marketable yield of 750 kilograms per hectare, which translates into a return on investment of 2.5 pounds per pound invested in our Stimulante Plus. If we look at the area under low intensity, light intensity, what we got is an extra marketable yield, as indicated earlier, of 1,400 kilograms per hectare. That translated into a return on investment of 4.7 pounds per pound invested in our product. Shortly, I'm going to talk now about what we are going to do this year. In 2021, we are going to test two products. One is Flower Power, one is Hold Plus. From the physiological point of view, Flower Power is a product that is there to promote cell division. We will apply it at the time of flowering, and the target is to increase fruit size, skin firmness. Hold Plus is a product that, from the physiological point of view, controls speed of ripening, and we target a better shelf life. We want to increase the shelf life of our production. What are we going to be measuring? Well, we will be measuring bricks, firmness, marketable yield. We will be doing this at each harvesting time during the whole season, and of course, we're going to be looking at shelf life. The objective, to show that the Stoller technology can give a return on investment to UK soft fruit growers. With this, I finish my presentation, and I don't know if you have time for questions, but please, if you have some, do ask. Thank you.
Thank you so much, Antonio. Again, very short, succinct, but very, very well presented. Couple of things, I suppose, to pick up on, if I may. Firstly, from a practical point of view, Antonio, you said that we need to do a jug test when mixing Stimulante Plus. What's the reason for that?
Well, Stimulante Plus contains a small amount of calcium within it, and that can give problems. So we always recommend to do that first.
Okay, and another question here really is perhaps for you or perhaps for Mark. If I know Mark's still with us, if he can unmute. Was the Stimulante Plus, so because obviously you've shown some good results last year, was it applied to one whole block within the wet centre? Was it done on a replicated basis? I may have missed that, but I just thought people may want to know that. I don't know if Mark wants to answer that question.
Yes, so it was all replicated in a statistically robust way. So we were able to determine the statistical significance of those results. So yeah. Good.
Okay, that's useful to know. If there's any more questions out there, please submit them now. We are coming to the end of our session this afternoon. I don't see any other questions coming through. So I think probably we will try and wrap it up. Because it's now gone to almost 4:10. So let's wrap things up, and hopefully you can see my wrap-up slides now. There we go. So thank you to Mark and all our speakers today. Thank you for keeping your presentation short, succinct, to the point. That always helps, and for putting things across so clearly. As I mentioned at the start, for those of you that are interested in the BASIS and Neuroso forms, hopefully you've downloaded those forms. Can you please fill those forms in now and send them to my colleague Claire Sayers-Smith at that email address, claire.sayers-smith@ahdb.org.uk. That's the BASIS code and the Neuroso code. If you can't remember Claire's email address, you can send it to me, scott.raffle@ahdb.org.uk. Similarly, if you have any late questions that you want to submit to me, please do so. I will pass them on to the presenters and they will get back to you. The recording, as I said, that we have been recorded this afternoon, that will be made available to you on our AHDB website next week. Now, just to finish off, just to tell you about some other webinars that you might be interested in, particularly if you're interested in soft fruit. Last week, I should say that we did an IPM webinar for strawberry growers on aphids and capsids. We are doing some more IPM webinars for the ornamentals industry, but actually I think they would be of great interest to those of you who are interested in crop protection in the soft fruit industry. So there are 2 webinars. The first is in May. Both of them have the same theme: selection and use of biological control agents in the production of ornamental crops. And the first of these, on Thursday, the 27th of May, from 4 till 5 p.m, focuses on aphids and whiteflies. And the second is in June, Thursday, the 17th of June, again, same time of day, same slot, 4 till 5, and that focuses on thrips and mites. Now, if you want to register for those or find out more details, you will find all the information you need on our AHDB website, ahdb.org.uk/events. Have a look on there and you'll find all that you need. So thank you finally to all of you who have registered and joined us this afternoon, logged on and followed it. Please do tell your colleagues if they didn't have time to join in, or if you want to watch back again, you can do so next week once our presentation and webinar has been uploaded to the AHDB. In the meantime, thanks again for joining us, and I do hope that you have a productive season. Thank you very much indeed.